So hi guys, welcome to my channel. So today I'll be solving this GFG problem of the day, which is clone a linked list with next and random pointer. So let's read the problem and try to approach this. So you are given a special linked list where each node has a next pointer pointing to its next node, and you are also given some random pointers where you will be given some pair denoting the two nodes like A and B, and A's random is equals to B random, means the random pointer is a pointer to a random node. Okay, so we have to construct a copy of a given link, means the whatever nodes we are given in the form of linked list and some next pointers and some random pointers, we have to make the exact replica of this. Okay, so let's see how we can approach this. Okay, so let's select one test case, which is linked list 1 2 3 4 and pairs 1 2 and 2 comma 4. Okay, so what here depicting is 1 to 2 means the random pointers of 1 will be pointing to 2. Okay, so the random pointer of 1 will be pointing towards 2. Let me make this as blue. And the random pointer of 2 will be pointing to 4. Okay, 2 will be pointing to 4. Okay, so done. Now we have to make the exact replica of this. Okay, so how we are making it? So the first step of R is to make the replica. If we are given that we only have to create the replica of the straight linked list, means the only nodes and the next pointer, then it is very easy. We'll be starting it like start looping from the first node and making the exact copy and run the entire loop. Okay, so let me make this. So we have created this. Now this is the better case than what it should be, because the random pointers can also point to like this 3 to 2 or 2 to 4. Okay, 2 to 4 is actually there, 3 to 1 and 4 to 2. So it could be like at every step we have to go towards the node and again go back to the further nodes and point that random pointer. So it's so cumbersome. So we can see here what's the time complexity if we are going towards each node and again pointing towards the random node. So what's the time complexity? Okay, so if we are standing at 1, we have created this one. Okay, its pointer is pointing to 2, so we will go one step ahead and point its random pointer to 2. Let's make this as okay, we have created. Now again coming to 2, 2's random pointer is 4. Now we have to go again 2 step ahead and mark its random pointer to 4. Okay, so let's create this 4. Okay, now again coming back to 3, 3's random pointer is 1, so I have to again start a loop and go 3's random pointer, mark it to 1. So you can see that the time complexity will become big of n square, because at every node we are standing, we are observing its random pointer and again starting the loop and pointing its random pointer to the corresponding nodes. So we have to optimize it. Now how can we optimize these? Okay, so what we are going to do here is we are creating a original versus clone map. Okay, this is the original and this is the clone that we are making, and we have to return the head of the clone. Okay, so we are creating this 1 corresponding to 1, original versus clone, 2 corresponding to 2, 3 corresponding to 3, and 4 corresponding to that will be 4. So we have created the next pointer of each of the nodes in our clone linked list. Okay, now we have to create the random pointer. Let's say start from this, means original head, this is clone head. So original head's random pointer is given to us, means it will be pointing 1 to 2. Now for clone head random pointer we have to point, so we have to go to 2. Now we'll be asking our map to give the original pointers clone, means the map has created the link this. Okay, this and this that I have created in the map. Okay, so let me make this. Okay, so this is how we have created the map, like node to node. Okay, so now we are standing at original head and clone head. This is 1 is pointing to 2. Now we don't need to traverse the whole node to find where we are going to set the clone head a random pointer. We have to set the clone head random pointer. Now how we can do this? Our original head is standing towards 1, our clone head is standing towards 1. We have to mark the original head's pointer, which is pointing towards 2, to clone head's pointer, random pointer, which will be pointing towards 2. So how we are going to do this? We are already provided with the pair, like what are the random pointers, like original head is pointing to. We'll get the nodes. Okay, so we'll get 2. One is pointing towards 2. Now I don't want to traverse the nodes to reach 2, so what I will be doing, I will give 2 directly to map and want the corresponding 2 towards the, like what is the clone corresponding to that original 2. Okay, so we get 2, so I'll be pointing 2. Now I'll be shifting. I'll finally writing the clone, like what are the steps here. This one I'll be completing the steps, don't worry. Now our original head is pointing to 2. Okay, so now I want original 2's random pointer is pointing towards 4. You can see original 2 random pointer is pointing towards 4. I want the current clone head random pointer will be pointing towards 4, but I don't want to traverse these. Okay, so how we are going to do this? We are going to 2's random pointer is 4. We get from here 2's random pointer is 4. Okay, 4. We'll give this to map. Okay, 4, and we'll take the clone corresponding to this 4, and we'll be pointing towards 4. Okay, so we'll be pointing towards 4. Now let's move this, and let's move this. Okay, now our clone head is pointing towards 3, original head is pointing towards 3. Okay, so 3's pointer is pointing towards 1. We don't want to traverse and get back to 1. We just directly need the clone head corresponding to this random pointer, and we'll be just pointing towards it. So how we are going to do this? 3's random pointer is pointing towards 1. We'll be giving towards to this map and want the corresponding clone. Okay, so we have given this 1, and we get the clone. Okay, so now let's point this. 3's random pointer will be pointing towards 1. Okay, done. Now let's shift it. Shift to this. Shift to this. Now we are standing at 4. The original head pointers random pointer is pointing towards 2. Now the clone head a random pointer we have to point, but we don't want to traverse like from the starting. So what we are going to do? 4's random pointer is 2. We'll be giving towards the map, so that we get the clone corresponding to the original node. So here we get 4's pointing towards 2. Now our our pointer will get out of range, both pointer, and will be stop the loop. Now you can see that we have cloned the linked list. Once random pointer is pointing towards 2, once a random pointer 2, 2's random pointer 4, 2's random pointer is pointing towards 4. Now 3 random pointer is towards 1, 3 random pointer is towards 1, 4 random pointer is towards 2, 4 random pointer is towards 2. We have cloned. Now let's write this step. Okay, so what we have done here, every time we have to mark the clone random pointer, because clone next pointer we have already make a replica, but we have to mark the clone's random pointer, random pointer. So how we are going to do? So what I have told here, every time I'll be asking the current original head random pointer. Current, or let's say I am standing at 2. I'll be asking the current original head random pointer. Okay, and give this to the map. Okay, so let's write in map what I'll be giving: original head random pointer. Okay, so in map I'll be giving original head random pointer. Let's say we are standing at 2. We have given 2's random pointer, 2's random pointer, 2's random pointer is 4, means 4 I'll be giving to map. Okay, 2's random pointer is 4, 4 I'll be giving to the map, and it will give the corresponding clone, and clone head random pointer means clone head a random pointer I'll be marking towards 4. Okay, so this is the main step. That's how we are going to solve this. Okay, so let's see the code. So what I am doing here is, first our main goal, which I have told you, to create the replica of the straight linked list. Okay, the straight linked list. So same I am doing here. Okay, so I have created a clone head which will be pointing to null, and clone tail which is also pointing to null, because I have to create a replica of the linked list. Now I'll be pointing temp is equals to head. Okay, so let me make this. So this is my original. This is my original, and I have to make the clone. Initially, clone head means, let me mark as head, and clone tail, which is also tail, is equals to null, pointing towards null. Okay, so now temp is equals to head. I'll be pointing temp is equals to head, means the original. Okay, so let's traverse. While temp do not reach at the end of this linked list, will be iterating. Okay, so while temp is not equal to null, insert tail, clone head I'll be passing, clone tail I'll be passing, and temp data means clone head I'll be passing. Okay, clone head I'll be passing, clone tail I'll be passing, and temp data I'll be passing. Okay, one. Okay, so now what clone tail insert tail is doing, I'll be creating a new node. Okay, let's create a new node. Okay, let's create a new node of the data which we have passed, 1. Now if head equal to null, okay, our head is pointing to null, then what I'll be doing, point head toward the first node, point tail to the first node. Okay, I have created head is equals to new node, tail is equals to new node, means the new node which I have created. Now finally return, don't move to this statement. Okay, so now head is pointing to null, new node, and tail is also pointing to new node. Now let's move again. Temp is equals to temp ka next. Now remove this temp, temp is equals to temp ka next. Okay, okay, so now our next step is to create the node 2. Okay, so we will be inserting, we have passed clone head, clone tail, and temp data, means 2. We have created a new node like 2. Now again asking if head is equal to null. No, head is not equal to null. So what we'll be doing, tail next is equals to new node, means tail which is pointing to 1, once next is equals to new node, means 2. And what I'll be doing, tail is equals to new node, then marking tail at the new nodes. Okay, similarly moving temp is equals to temp ka next. Now again 3, I'll be making the node 3, pointing tail next is equals to 3, then pointing tail is equals to there. Then I'll be again moving to 4, create a node 4, tail next is equals to 4, then remove this and created a tail here. Okay, so this is how we have created the replica of this. Now next step is to, we have created a map like old to new or original to copy. Okay, original to clone. Okay, so next step what I'll be doing, original is equals to head and clone is equals to clone head. Okay, let's say here original is equals to head and clone is equals to clone head. I'll be moving one by one, original also one by one, and do the mapping. So map of original is equals to clone every time. Map of original is equals to clone, map of original is equals to clone, map of original is equals to clone, and every time moving the next pointer, means map of original is equals to clone, and every time clone is equals to clone ka next, original is equals to original ka next, while original not equal to null, clone not equal to null. Now again I'll be pointing original is equals to head and clone is equals to clone head. Okay, now again I'll be pointing original is equals to head and clone is equals to clone ka head. Okay, so now our next move is to, while original not equal to null, what I'll be doing, while original not equal to null, now I have to make the random pointers of each node. So what I'll be doing, clones random is equals to map original ka random. Okay, the same step which I have written, clone random is equals to map of original ka random. Okay, clone random is equals to map original ka random, and moving original one step ahead, moving clone one step ahead, and finally returning the clone head. Okay, so let's run the code. Let's submit it. Okay, so it got passed. Let's discuss the time complexity. What's the time complexity? Means we are traversing the linked list in linear time, so the time complexity will be equal to big O of n. Okay, now what's the space complexity? Means we are using the map, so our space complexity will be, let me write this. Time complexity will be big O of n, and space complexity will be bigger of n. So but so here we are asked to solve this problem in time complexity as big of n and space complexity as big of 1. So I'll be uploading one more video where I'll be solving, like I'll be eliminating the use of map. So till then I have created a video on time as big of n and space also big of n, and in next video I'll be eliminating the use of map. Thank you for watching and having patience. So thank you.